Hi everyone, I am Manish Kumar, studying in Sri Venkateshwar Engineering College, civil from Civil Department. Today the topic is Newmark's influence chart along with its constructions and applications. The contents are introduction, objectives, methodology, applications, advantages and disadvantages, conclusion. Introduction. Newmark's influence chart, also known as Newmark's chart or Newmark's method, graphical tool used in structural engineering to analyze the dynamic response of structures subjected to earthquake forces. The chart was developed by Nathan M. Newmark in 1959 and has since become a widely used technique for seismic analysis. The construction of Newmark influence chart involves two steps: calculating the displacement and velocity of structure to each time interval and then plotting the results on a chart. The chart has two axes. The horizontal axis represents the maximum acceleration of ground motion and vertical axis represents the displacement of structure. To use Newmark's influence chart, the engineer must first determine the natural frequency of the structure and the time steps of analysis. Then the ground acceleration time history input into the chart and displacement and velocity of structure are calculated as each time step. These values are not plotted on the chart. The engineering and can be determined the maximum displacement and corresponding ground acceleration. Newmark's influence chart is useful because it allows engineering to analyze the response of structure, different ground motion inputs of determine the maximum displacement and acceleration that structure will be experienced. It is also useful for comparing the response of different structural systems and optimizing the designs of structure to withstand earthquakes. In summary, Newmark's influence chart is powerful tools and analyzing the seismic response of the structure and optimizing their design. Its constructions involve calculating the displacement and velocity of the structure at each interval and plotting the results of the chart, which allows engineering to determine the maximum displacement and acceleration that the structure will experience. Objectives: determine the maximum displacement and acceleration that a structure will experience under a given ground motion input, evaluate the dynamic response of the different structural systems and compare their performance under seismic loads, optimize the design of structure to ensure that they can withstand the effects of earthquakes, assess the effectiveness of different seismic report techniques for existing structure, improve the safety and of structure in earthquake prone regions, incorporating the results of Newmark influence chart analysis into the design process. Construction. These are the construction of Newmark influence chart, and the equation is delta sigma z is equals to p dot 0 by 100 into n. Determine the natural frequency of structure. The first step of this determine to the natural frequency of structure. This can be done through analytical calculations and experimental testing. Determine the time step of analysis. The time step of analysis interval between successive calculations of displacements and velocity of the structure. It should be small enough to capture the dynamic behavior of the structure accurately, but large enough to keep analysis computationally efficient. Input the ground acceleration time history. The ground of acceleration time history is input in signal used to simulate the earthquake motion. This can be obtained from the seismic records or other records. Calculate the displacement and velocity of the structure using the natural frequency of the structure and ground acceleration time history. The displacement and velocity of the structure can be calculated for each time step. Newmark's methods used as a numerical integrations scheme of the perform to calculations, plots the results of the chart. Once the displacement and velocity of the structure are being calculated for each time step, They can be plotted on the Newmark influence chart. The horizontal axis represents the maximum ground acceleration and vertical represents this displacement of the structure in terms of ratio of the maximum displacement to the maximum displacement under the static load. Determine the maximum displacement and acceleration. The maximum displacement and acceleration of the structure can be determined from the chart by identifying the intersection of the float of the displacement and plot the ground acceleration. Overall, the construction Newmark's influence chart involves numerical analyzing bridge structures. Newmark's influence chart is particularly useful in analyzing the behavior of bridge structures by the plotting the influence line of the particular point of the bridges. Engineers can calculate the maximum stress and deflection caused by the pausing load. Application determining the maximum bending moment. Engineer can use Newmark's influence chart to determine the maximum bending moment at any point of the beam by plot of the load and influence chart reading corresponding moment value. Engineers can quickly calculate the maximum bending moment. Design structural members. Engineering can influence chart design structural members such as beams, columns and trusses by analyzing the load distribution of the structure. They can determine the most critical points and design the members accordingly. Evaluating the effect of moving load. The influence chart is also useful evaluating the effect of moving load on a structure. Newmark influence chart is useful graphical tools in structural engineering for analysis the effect of loads on structure. It allows engineering to determine the maximum bending moment, design structural members, evaluate the effect of moving load, analysis bridge structure and optimize the structural design. The influence chart provide a visual representation of the load distribution on the structure which helps engineering to inform discussions about the designs and safety of structure. As the result, it is valuable tool in design and analysis the structure, especially in the field of civil engineering. These are the conclusion and these are the applications which are used in Newmark engineering method and some importance which I informed here in the construction, and this is the information of the Newmark influence chart. Thank you.